Hi, welcome to my channel, Math Made Easy with Laurel. This video is a continuation of finding volumes using the washer method. In the previous video, we talked about how we could find the volume of a solid that's generated by taking an area and revolving it around the x-axis. Now what we're going to do is take a look at taking that same area and revolving it around the y-axis. So in order to do that, we're going to use horizontal rectangles. And again, if we take that representative rectangle and rotate it around the y-axis, it will form a washer. And we know the volume of a washer is this, where large R is the outside radius and small r is the inside radius. Again, we're going to sum all of those slivers or those rectangles that form washers from C to D, and we do that by finding the integral. So the formula that we're going to use, volume will equal pi times the integral from C to D, so the y values, not the x values, of the large radius, so that's the outside radius, so that will be f of y squared, minus the inside radius, so that's the function that's closest to the y-axis, so g of y squared, and the height is dy. So very similar to what we were doing with vertical rectangles, but we're using horizontal rectangles, which means we have to do everything in terms of y, the function as well as the limits. So let's take a look at how we can use this formula to calculate volumes. Okay, our first example asks us to find the volume of revolution generated by revolving the area enclosed by y equals 1/2 x squared, x equals 4, and the x-axis around the y-axis. So always pay attention to where that area is rotating around. So we're going to draw our curve. So y equals 1/2 x squared is the general shape of y equals x squared. X equals 4, the x-axis, and so the area bounded by those three curves will be this here. If that was revolving around the x-axis, we would be using a different method. We'd be using this method, but in this case it's revolving around the y-axis. So we're going to use a horizontal rectangle to do this. And in order to do this question, we need to know our y values. And we need to know our functions in terms of y. So if y equals 1/2 x squared, then x squared will equal 2y, and x will equal the square root of 2y. This point of intersection will be when this x value is equal to this x value. So points of intersection will be when square root of 2y is equal to 4. We square both sides and we divide by 2. So this y value here is 8, and we know that this y value is 0. So we've got the limits for our integral, and we've got our two functions, this function x equals 4 and this function x equals square root of 2y. We plug into our formula. So our integral is from 0 to 8. F of y, that's the function furthest away from the y-axis, which would be x equals 4, so 4 squared, minus g of y, which is the function closest to the y-axis, which would be square root of 2y squared dy. Let's simplify this. So that will be 16 minus 2y. And now that it's simplified, we can integrate. So that will be pi times 16y minus y squared. Then we evaluate it. 16 times 8 is 128, minus 6 squared is 64. So our volume will be 64 pi cubic units. Let's try another example. Our next example says find the volume of revolution generated by revolving the area enclosed by y equals x squared and y equals 4x around the y-axis. We actually did this example in the last video, but we revolved it around the x-axis. And I wanted to do this one because I want to show you that the volume is different depending on which axis you're rotating around. So let's draw this. Y equals x squared, y equals 4x. So that's our area that we're revolving, and we're revolving it this time around the y-axis. So we're going to use horizontal rectangles, and we need to find our y values of intersection this time instead of the x, and we need to define our functions in terms of y. We found the points of intersection before by letting the y values equal each other, and we found the x values. So we know that we had 0 and 4. But because we're using horizontal rectangles, we need the y values. So when x is 0, y will be 0. And when x is 4, y will be 4 squared, or 4 times 4, 16. So it's important that we use the y values, not the x values. Then we set up our integral. We know it's 0 to 16, and we have to define our functions in terms of y. So if y equals x squared, then x is equal to square root of y. And that will be this function right here, x equals square root of y. If y equals 4x, then x will equal 1/4 y. So that's this function here. So our outside function, in this case, it's the function the furthest away from the y-axis, will be square root of y. Square root of y squared. Minus the function closest to the y-axis will be 1/4 y squared. So this is like the outside radius, this is the inside radius. We're going to simplify this. So that will just simply be y, and this will be 1/16 y squared. And now we can integrate it. So it will be 1/2 y squared minus 1/48 y cubed. To evaluate it, I put 16 in for y, and when I put a 0 in, it's just going to be 0. So I calculate this. As a fraction, it's 256 pi over 3 cubic units. As a decimal value, it's 268.1 cubic units. And if you take a look at the previous video, when we did this question and took this area and rotated around the x-axis, we got 400 and something cubic units. So you do get a different volume depending on which axis you're rotating around. There's a third method of calculating volumes that's necessary because sometimes the disc or the washer method's not going to work. So I'll talk about that in the next video, but in the meantime, practice doing the washer method either around the y-axis as well as the x-axis. Take care, and we'll see you on the next video.